So we have a very specific piece of hardware on the desk today. It's the NTI ST-C5V-R-600 VGA receiver.
That's the one.
But before we even get into what it does, I have to ask the obvious question. It's 2026.
Yeah.
Why are we doing a deep dive on a device for VGA? Isn't that the clunky blue connector from like the 90s?
It is exactly that clunky blue connector. And I get the skepticism, I really do. In a consumer world, with HDMI and DisplayPort, VGA feels like a dinosaur.
Right.
But in the industrial and commercial world, VGA is, it's more like a cockroach. It just refuses to die.
Cockroach. Okay, I like that. So it's robust.
Incredibly robust. And we're not talking about your gaming setup here. We're talking about infrastructure.
So like a factory floor or an airport.
Exactly. Imagine you're running a hospital or a huge digital sign in at a stadium. You'd need your computers locked away, right? Safe and cool in a server room.
Sure.
But the screens, the monitors, they need to be hundreds of feet away where people can actually see them.
And you're definitely not running a standard VGA cable that far. I mean, the signal would be complete trash after 50 feet, if that.
Right. And that's where this NTI unit comes in. It solves the distance problem because for the long haul, it ditches the video cable entirely.
So what does it use instead?
It uses the wiring that's probably already in your walls. Standard CT5 or the TT6 cable.
You mean like internet cable?
The very same. It's an extension system, really. You have a local unit at the computer, which could be a PC, a Mac, anything.
Okay.
That converts the video signal. It shoots it over the CATx cable, and then this receiver, the unit we have here, reconstructs it at the monitor.
And the claim on this is, what, 600 feet? That's almost 2 football fields.
600 feet or 183 meters. It's a massive distance for an analog signal over copper.
That seems ambitious. How does the quality hold up? I have to imagine it doesn't look great at the other end.
Well, you're right to be suspicious. There is some unavoidable physics at play. NTI claims this is the sharpest and clearest VGA quality over CT5 of any manufacturer. But
physics is physics.
Exactly. It's a sliding scale. If you're only going, say, 100 feet, this receiver can put out a super crisp 1920 by 1440 image.
That's better than HD. That's actually impressive.
It is. But if you push it to the maximum, to that full 600-foot limit,
what happens then?
the resolution drops. The max you can get is 1024 by 768.
So we're back to laptop resolution from maybe a decade ago.
Which, for a digital sign showing flight times or a control panel on factory floor, is perfectly fine. You're not doing color-critical work at 600 feet.
That's a fair point.
But to your point about the signal degrading, this is where the device gets clever. It has a video quality adjustment feature.
Is that just like a fancy brightness knob?
No, it's more like an equalizer for the video.
Yeah.
Different lengths of cable have different electrical properties, so this has a manual dial to, tune the circuitry.
So you tune it to the specific cable you're using.
Precisely. It sharpens the image. It even has a built-in test pattern to help you get it just right so you're not squinting at your screen trying to focus it.
That's smart. Now, I saw something else on the spec sheet. Surge protection. At first, I thought that was just boilerplate.
Oh, no. That is definitely not boilerplate. Think about it. You've just strung a copper wire the length of 2 football fields through a building.
I've built a giant antenna.
You have built a very efficient antenna. It's going to pick up interference, spikes from heavy machinery, everything. Without surge protection, you don't just risk a glitchy image. You risk frying the monitor or even the computer back in the server room.
So the receiver is also a gatekeeper, a firewall for electricity.
Exactly. It safeguards the hardware on both ends.
It's all starting to make sense. This is really about reliability, about using what you've already got in the walls to do something really difficult.
That's the key takeaway.
It brings up a really interesting final thought, though. We always think of digital as being better than analog, but here, VGA being analog is almost a feature, isn't it?
It absolutely is. I mean, think about the digital cliff. The digital cliff. With an HDMI cable, if the signal is 99% perfect, you get a picture. If it degrades just a tiny bit to maybe 98%, you get a black screen. It either works or it doesn't.
Whereas analog, it just gets a little fuzzy.
Exactly. Analog fades gracefully. And in a mission-critical environment, seeing a slightly fuzzy warning light is infinitely better than seeing nothing at all because your digital handshake failed.
That's a fantastic point. Sometimes the old ways are the only ways that work at 600 feet. Thanks for the breakdown.
My pleasure.
And thank you for listening to this deep dive. Go check your cables.